So with our sine graph, why is this not showing up? There we go. With our sine graph, it normally, would look like this. So if we want to use sine, we would need to move that graph over to the right. How far is that? That is pi over 2. Right, and so if I took 2 sine x and moved it to the right pi over 2, it would match up with this graph. Which one of these right here moves it to the right? The one where it's subtracting. So this one is correct. This one right here is also correct. And I think it should just be those two. So if you did not choose those, go back and choose them now. And unchoose these others here. Now, these are not the only two options. There's other things you could do. You could take cosine and you can move it over pi, but that's just not an option here because it's multiple choice. Okay, questions on that one? All right. Let's look at the next one. And so for this one, let me erase what I had. The most popular answers seem to be sine of 2x plus 3 and this cosine of 2x pi over 2. So let's look at these. I see a midline of 3 right here. Pretty much, actually, almost all of them have midlines at 3. Which one does not have a midline at 3? This top one right here, that 3 is not on the outside, so that is not correct. And amplitude of 1, which means you will not have a number in front, so that looks good for, they're all okay that way. So we're looking at these 4. Sine has a y-intercept at the midline, and it's going to increase after that. So if we use sine, we don't have to shift this one left or right. What's the period for this graph? Okay, it takes me over to here to start to repeat again. So the period is pi. We do not take pi and plug it in, right? Remember, our period is 2 pi over b. So in this, and b, we're going to have sine of bx plus c, what's your d over here, a, right? So that b value is that number in front of the x. And so to get a period of pi, you need your b to be 2. 2 pi divided by 2 would give you pi. So we need a 2 right there next to the x. So this one is correct, sine of 2x plus 3. Does that make sense? Okay, so there may be a cosine graph that also matches. The good news between like sine and cosine is the only real difference is a phase shift. So midline, amplitude, and period should all be the same. So we would know it is, if cosine works, it is not going to be this bottom one because it has a different period. It's got x over 2, which is like having 1/2 x. So it is not going to be that bottom one because the period for it would be 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. So it is not that bottom one because the period would be different for it. So if there is one that works, it's going to be this one right here, but we need to know for sure if it is. Cosine, if I use a different color here for cosine, cosine would normally have a y-intercept at the maximum point, right? So I need to move this to the right. How far? Are you sure? It's just this little block. This way over here is pi. There are 4 blocks, 1, 2, 3, 4, that get me to pi. So this would be pi over 4. Does this have a phase shift of pi over 4? Yes. It doesn't look like it does, but it does, right? Because how do we find phase shift? Is negative c over b. So in this case, that would be pi over 2, that's your c right there, over, right here is your b, so divided by 2, which we can make 2 over 1. So dividing fractions is easy as pi, flip second, multiply pi over 2 times 1 over 2 is pi over 4. That would move it, since we have a minus right here, it moves it to the right, so this one is also correct. So you should have sine of 2x plus 3. You should also have cosine of 2x minus pi over 2 plus 3. Okay, questions? All right, let's look at the next one. Look at all my writing here. We're looking better here. It's appearing that these two are probably correct. So if we just look at it real quick, midline at negative 1 means you need to have a minus 1 on the end. These 3 do. We have a y-intercept at the midline, and then we go up from there. So sine is going to be your best bet. What is your period for this graph? You start repeating right here, which is the distance of 2 pi. So you don't need a number there on the inside. So sine x minus 1 definitely works. Let's see if cosine will work. Cosine would typically have a y-intercept at the maximum. So we would need to shift it to the right this far to get it to match up. How far is that? Pi over 2. So it's halfway to the pi that we see over here. And so if I have a minus pi over 2 right here, that shifts it right pi over 2. So this one is also true. Okay, our last one is our matching, and let me see if it'll, well, just let me, oh, it doesn't even tell me who's right here. We're just going to pick on Ruth, because she has a name that's fairly easy to pronounce. Alright, so let's look at how Ruth has done for each of these. I'm just going to start with this one right here. So we have 5 minus 2 sine x. I really don't like the way that's written. It could be written like this. Y equals negative 2 sine x plus 5. So amplitude is 2. This graph has an amplitude of 2. What's the midline supposed to be for that? Midline should be 5. Does this have a midline of 5? It does not. So Ruth has messed up. Will it let me? I don't think. Oh yeah, it'll let me work on Ruth's here. So if you're Ruth, I'm going to fix yours for you as we go through it. Okay, so which ones do have midlines of 5? This one here and this one here, right? So I need to think about which one of these would be sine. So I see here I've got a minimum point is my y-intercept. This one, the midline is here, but I go down instead of up. Is that correct for this? What do I have right here? I've got a -2, right? What's that negative do? It flips our graph. So sign here has been flipped, which means it will go down instead of up first here. So so this does match with this one right here. So the one that has a midline at 5 and has a y-intercept on that midline and then goes down and then up. That one does go with 5 minus 2 sine x. So you can fix yours if you don't have it right. Over here, let's look at this one. It's similar, but it's cosine. So again, you can write this like this. Y equals -2 cosine x plus 5. So what is your midline supposed to be here? It is supposed to be 5. This has a midline of 5. Cosine is supposed to begin at, or have a y-intercept at a maximum point. Why would this one have a y-intercept at the minimum? It has also been flipped, right? So that flips at maximum to make it a minimum instead. So this one is matched up correctly. So Ruth had that one right. Okay. Questions so far? All right, so these two right here that we have left, midlines should be at 0 on both of those. That looks good. Amplitude should be 2 on both of those, so that's not going to help us distinguish, right? Sine should begin at the midline and then go up and then down like this, right? So if I want this to be sine, I would have to shift it either to the right or the left. How far? Actually, look, hold on. Let me see if it'll let me erase that, because that's not really what I want to do. Let's shift. Let's not go maximum to maximum. Let's go from here to the next. Right there. So how far do I have to shift it? Pi. And I really could go right or left, so it doesn't matter whether we have a minus or a plus. So this one right here needs to go with our sine. It also makes it look like it's been flipped, right? But it hasn't. It's been shifted here. And then, so this would be cosine. Cosine normally would have a maximum right here. So you'd have to shift it to the right pi as well on this one. This one has been shifted right pi. So that those two go together. Okay, questions? All right, so we're going to do some more practice with this today. And let's see, I think let's do, I did homework first because I knew we had some issues because there were a lot of X's on the page there. So now that we've done that, let's do a warm-up. Okay, so grab a warm-up. We have been slacking on the warm-ups. What day are we on? 3.
The last one we did was on November 17th.
We don't do anything there.
Okay. All right, so for these, I want you to find period, midline, amplitude, and phase shift for each one. I use a theta instead of an x here just because I want you to see both. Sometimes they use thetas. I know. And there's a little bit of a trick right here, or it might be tricky to some of you. What is that? It's theta over 3. It's the same as 1/3 times theta. So whenever you see it written like this, theta over 3, it can be written as 1/3 theta. So your B value there, if you're talking like A sine BX plus C plus D, the B value there is 1/3 on that problem. It can be a little tricky whenever it's written like that. This is basically just following those formulas of the things that I have given you. So, let's see, Caleb, what would we do for the period for number 1?
Period is
2 pi over b. And what is b for this problem? 1/3. So, dividing fractions is easy as pie. Flip the second and multiply. 6 pi is our period for this graph. Okay, so that's what you do every time. If you are given an equation and you're asked to find period, 2 pi divided by the b value. Okay, let's see, Lucian, what'd you get for the midline?
8.
Very good. And you want to say y equals 8 there because it needs to be the equation of a line. Okay. All right. For the amplitude, Leah, what do we get for our amplitude on that one? Perfect. Okay. And let's see, Macy, what are we going to do to find our phase shift? Perfect. And dividing fractions is easy as pie. Flip the second and multiply. What do we get for our answer? 6. And would this go right or left? Left. When, you can do it either way. So what I have done here is I've ignored signs and just done 2 divided by 1/3. And then at the end, I looked at it and said, oh, because that's positive right there, it's going to move it to the left. So you can do it that way. Or if you want, you can do negative C over B. And you will get to negative 2 times 3 over 1, which will give you negative 6. And that negative tells you that it's left. If this right here is negative, it will go to the left. And if that number right there, or if that sign right there is positive, it will go to the right. If you're doing the negative C over B, what that does is it includes the direction in your answer. So this negative right here is what's telling you left. Does that make sense? Yeah. Yeah. So if you include, like if you do a sign on this, if you pay attention to signs, that sign that you get at the end tells you whether it's going left or right. So if it's negative, it's left. If it's positive, it's right. If you ignore signs, then you have to look at whatever sign you have here, and then that tells you left or right. And if you're doing it that way, remember in the parentheses, you got to use opposite direction. If you do it this way, it's kind of like included for you. I kind of prefer doing it the first way, just ignoring signs, because what we have always known is still true, right? So if I add 2, that's going to move it left, right? So the things that we already knew are still true. So if you do this, you might kind of get confused with left and right and stuff like that. So I usually wait till the end and look at signs, but it can be done either way. Yeah. Okay, questions there? All right. For number 2, let's see, Luke, how are we going to find the period for this one? 2 pi over 3, nothing to reduce or simplify there, so that's just our period. Let's see, Kayla, midline.
0.
What equals 0? Y equals 0. Good. Give it as an equation of a line. And let's see. And what's our amplitude? 2. Those 3 are much easier than phase shift if you have one. All right. Joshua, what would we do for our phase shift? Good. So we're doing pi over 2 divided by 3. And we can put that over 1 because dividing fractions is easy as pi. We're going to flip the second and multiply. What will we get, Joshua? Pi over 6. And which way? Right. Okay, questions? All right, if you have your computers open, please shut those. We will not need them. Well, we might need them there, but I don't want you using them right now. So, yeah, well, that's what this is going to be. That's what we'll be doing. Hold on. I gave you guys an extra, 2 extra on it. Here. Is that. Here. Alright, extra. Alright. Okay, we're going to do a couple of these together to get us on the right track.
Wait, no, I don't have one. That was mine.
Make it look like you had one there. I asked him if he had one because it didn't look like he had one there, but he told me, oh yeah, I've got one. All right. Okay. Let's see here. Anybody else? I think I already gave Morgan one. That's why I don't have 3 extra. Okay. Okay. Now, in my opinion, of course, I know the rules very well because I've taught this for a long time. I think what we just did on the warm-up is easy. I know the rules well, so that's why I think it's easy. So you guys are new to it, so if it's a little confusing, you just need to practice a little more with those rules. But it's pretty much straightforward. These are the rules, you follow them. Okay? So what we're getting ready to do on this, and we looked at some yesterday, is more difficult because you're kind of going backwards. So I will not ask you to graph anything by hand, but I will ask you to write equations for graphs. So, you do, although you don't have to be able to graph something by hand, you need to be able to match an equation to a graph, or write an equation for a graph. So let's look at this worksheet. Where is it at so I can open it? Right here. And we're going to do, let's do number 3. All right, so everybody look up here. We're going to do number 3 together. Okay, so if you already know everything about everything, you can work on something else, but don't ask me a question about number 3 if you do that. All right, so we need to write an equation for number 3, and this does not tell you whether you have to write a sine or a cosine equation. In fact, I would like for you to try to write both, okay? Because you could write either one, okay? So some of these, it will be easier to write one than the other. Others, it doesn't really matter very much. So I think that there are a couple things that are easy to see from the graph. One of those is the midline. It's just your halfway point. So if we look at 3, where is our midline? It's right there at 0. So has this one been shifted up or down any? It has not. Okay? Then I can look at my amplitude. I think that one's pretty easy to find. It's just your distance from your midline to your maximum or to your minimum. What have we got here? 2. So we know our equation is going to look like this. Y equals 2 times whichever function we're going to try. Okay? So if we look at our y-intercept, that can sometimes help us decide whether to choose sine or cosine, but does it help us here? No, because it does not intersect that y-axis at a maximum, a minimum, or the midline, right? So really, in this case, whenever you don't have that happen, it doesn't really matter whether you sine or cosine. They're both going to have phase shifts here, which is one reason I chose this one. All right, so before we do anything, we need to know, before we do anything else, period, midline, amplitude and midline, those can be done before you think about anything else, because that's just your number out front and then the number added or subtracted to the end, and it doesn't matter which function you pick, what the period is, what the phase shift is, those are going to be the same. So those are the easier parts to find, in my opinion. After you have found amplitude and midline, period has to be found next, because if you don't know the period, you can't do phase shift correctly. So for period on a graph, I always look wherever the y-intercept is. And you want to see, if you look at your graph, if you follow it, you want to see when you start to repeat. You do hit the same point right here, but have you gone all the way through a full cycle? You have not. You got to do this little downward part here, and you end up right here. Okay? So you're starting at the y-axis and seeing how long it takes you to get a full cycle back to that point. How far was that? It is 2 pi. So 2 pi is great. That means that we are dealing with one that does not have a b value, a number in front of our b. That makes our phase shift much easier. Okay? So for this, it really does not matter whether we choose sine or cosine on this, because either one is going to have a phase shift. So let's just do sine first. Sine of, and you can use an x or a theta. I think I'll use a theta today. Feeling fancy. So we've got a theta here. We don't have a number in front of it because our period has not changed. So Sine, typically, if it has not been shifted, has a y-intercept at the midline, all right? So sine would look like this. So we have to move sine. We can move it way far to the left. The easiest move is going to be to move it to the right, just this little tiny bit right here. Now, sometimes it's hard to tell how far that is.
Aren't you moving like the graph itself, or are you moving like what should be the graph?
Think about where sine would be. So this, what I've graphed right here, that's where sine would be if I had not shifted it left or right. So I'm thinking about like my original sine graph. How far do I have to move it to the left or right to get it to match up? So don't think about moving the graph you're looking at back to be sine. You want to think about taking what sine would look like if it had not been shifted and moving it to match the other. Does that make sense? Okay. All right, so Caleb says maybe pi over 3. I don't think that's right. Okay, let's think about it here. All right, let's think about it. So this right here is 2 pi. And there are 4 blocks right there to get to 2 pi. So that means if I'm taking 2 pi and dividing it by 4, that means each one of those little tick marks is pi over 2. Right, so this tick mark right here would be pi over 2. But this appears, and it's okay to make the assumption here, if it looks like it's halfway, just assume it's halfway. That appears to be halfway between 0 and pi over 2. So half of pi over 2 would be pi over 4. So I think Luke is right. That distance right there is pi over 4. I want you, yes, I'm requiring you to use both. Yes. Because what's going to happen for these is that on a quiz or test, I'm not going to tell you which one you've got to do. It's just going to be multiple choice. I don't think I have any there like I did on the homework where you choose both. But you might think sine is easier. I might have done cosine. So you need to know how to do both because it could be either answer. Okay? So I do want you to practice doing both here. All right, so if I want to move this to the right, pi over 4, there was no period change, so this is very straightforward. You just have to do minus pi over 4. So that would be our equation for 2 sine of, that would be our equation for our graph here. Any questions on that part? All right, let's back up. Let's think about, I'm going to erase what I've got here. Let's think about doing this same thing for cosine. The good thing about it for cosine is that amplitude stays the same, period stays the same, midline stays the same. The only thing that's going to change is your phase shift if you're using cosine instead. So everything about this equation should be the same except for the phase shift. So cosine, originally, if I have not shifted it left or right, would have a y-intercept at a maximum point. So I could move this I could move it to the right or to the left. It really doesn't matter. I will say that usually on multiple choice sort of things, I've moved it the shortest distance, right? So it would be a little bit shorter to move it to the right here. How far is that? Oof. What? Well, let's see. Because I think Luke is right, but a lot of you seem very confused at that. Okay? I think Luke is right. All right, so again, let's think the same thing we were before. Right? This distance is 2 pi. there's 4 blocks there. So 2 pi over 4, 2 pi divided by 4 is going to be pi over 2. That means this little first block right here is pi over 2. That means this next one would be 2 pi over 2 if I wanted to count it that way, or I could just call it pi. Right? So this, we are looking at the point halfway between, and halfway between, you could think of unit circle, right? Pi over 2 is here. 2 pi over 2, or just pi, is right here. What is halfway between? That would be 3 pi over 4. You could think of unit circle. You could just think of like averaging those two. If you do pi, like to average, you add together and divide by 2, right? Pi over 2 plus 2 pi over 2 divided by 2. So that'd be 3 pi over 2 divided by 2. 2 over 1, dividing fractions. As easy as pi. Flip the second, multiply. You get 3 pi over 4 there. Another way to think about it is on the last one we said this little amount right here was pi over 4. So this would, if that is pi over 4, then I could count this way instead. If that is pi over 4, this would be 2 pi over 4. This would be 3 pi over 4. You could keep counting like that, but 3 pi over 4 is what you would need there. So it's really all just thinking like fractions there. If you know this is 2 pi, you're splitting into 4 equal parts. You're counting up. Because, sorry, that should be a minus. Basically, sine and cosine are like a pi over 2 off from each other. Like if you take sine and shift it pi over 2 to the right, you'll get, no, pi over 2 to the left, you'll get cosine. So there's like a pi over 2 difference between them. So where we had to shift this one pi over 4, cosine needs to be shifted like pi over 2 further than that. So you can always get sine and cosine to line up. The shifts will have to be different distances though. And if there's no period change, that the difference will be pi over 2. If there's a period change, it might not be pi over 2. Okay, questions there? All right, I think it would benefit us to do one like number 5. And then we're going to look at one on the back as well. I'll let you guys work. So, period, amplitude, midline, amplitude are the easiest to find. So look for those first. And first of all, does it matter whether we use sine or cosine on this one as well? This one, our y-intercept right here, it's not a maximum, it's not a minimum, so it's like the last one. This one is going to have a phase shift. So it really doesn't matter whether you use sine or cosine first. Either one's going to require a phase shift. So let's do sine first, just because it really doesn't matter, but let's just do it. So, so I'm going to have y equals, what's my amplitude? It is 1 there, because if you look at your scale right here, that's 2, that's 4, so it's 3 in between. So I don't have a number out front. I'll have sine. I'm going to leave the inside alone right now. What's the midline? Plus 2 on the end. And if I want to go ahead and think about cosine, it's going to look the same, right? I'm going to have cosine. Something's going to happen on the inside. And I'll have a plus 2 on the end as well. So, I need to now think about the period of this graph. So if I look at my y-intercept and I trace this graph until it starts to repeat, it would start to repeat right here. How far is that? Pi over 2. So my period for this one equals pi over 2. That number does not go into my equation. I'm going to go ahead and put bx plus c right here. Okay? So I don't plug that number into my equation. I need to find the b that will give me pi over 2. All right? So you may be able to figure this out just in your head. If you can, that's great. But what we can do every time, even if it's like a complicated number that we're having difficulty figuring out, is we know to find the period, we do 2 pi divided by b. And that should equal whatever we want the period to be, which in this case is pi over 2. So your formula for period, this is always the same, right? You can set it equal to the period that you want to have. And you could probably do this in your head, because if b is 4, that reduces to pi over 2. So b is going to be 4. Or if it's a difficult one where you can't figure that out just by looking at it, you can solve this by cross multiplying. So you would have pi times b equals 4 pi. And then you could divide both sides by pi. And b would equal 4. So we would have y equals sine of 4x plus c plus 2. We're not done yet, but we're getting there. Are we okay here? That little equation I just set up will work every time. Because you'll see some where you get really crazy answers that are hard to figure out. Not so much with graphs, but definitely with the other ones when I say on the back. All right. Now, if I'm dealing with sine looks like this. It has a y-intercept on the midline. That needs to be shifted this far. Just one little tick mark. Oh, gracious. What is that? Excuse me. Yes, pi over 16. Because this right here is pi over 4. And there are 1, 2, 3, 4 tick marks to get there. So if we do pi over 4 divided by 4, it's like 4 over 1. Dividing fractions is easy as pi. With the second multiply, we'll get pi over 16. So we need our phase shift to be pi over 16 to the right. However, we have a b, correct? Since we have a b, we know that we need to use that formula. So for phase shift, the formula is negative c over b. I'm just going to do c over b. Should that be since I'm going to move to the right, should this c right here, should it be a positive or a negative? It should be a negative. So I'm just going to like already assume I know that and then ignore signs. Because sometimes I can get a little backwards with my signs if I don't do that. So c over b is going to equal your phase shift. Well, I already know b. I found b, right? So I can say c over 4 equals my phase shift, which is pi over 16. We okay here? That one I really don't know how to figure out just looking at it very well. So just cross multiply here. You get 16c equals 4 pi. And divide by 16. So c equals pi over 4. So that c value is pi over 4. Our equation for sine is going to be y equals sine of 4x minus pi over 4 plus 2. That is one of our answers. Yes?
Okay, I'm confused. So I did c over b, so I did pi divided by 16 and then divided by 4.
Our b is the number that we just found on the last one. That is 4.
Yeah, so I did pi over 16 divided by 4 for C over B.
Now, okay, so it's not asking you to find the phase shift. You're finding C. You don't know what C is, right? So C is what we do not know. So we've got to do C over B, which is 4, right? Because we already know that B is 4 right here. C over B should equal our phase shift. We found our phase shift. We know we need to shift this to pi over 16 to the right. So we're going to say C over 4 has to equal pi over 16. Does that make sense, the difference there, Sophie?
So when you're finding the phase shift, we can take that number and divide it by.
Yeah, so, and you can double check, because like you were doing on the warm-up, the formula for phase shift is C over B. So C is pi over 4, and B is 4, right? So when you get your equation, if you check your phase shift, pi over 4 times 1 over 4 would give you pi over 16, and you can see from your graph that's what you wanted to have. So we're going backwards here, so we're not going to take the phase shift and divide. We are setting up that equation for it. All right, so let's do the same thing for cosine. Let's back up. Try this for cosine. I'll have to erase some so I have room here. Erase what I've got here. Cosine usually has a maximum point right here. So I need to shift it to the right 3 tick marks. How far is 3 tick marks going to be?
3 pi over 16.
Good, because if this was pi over 16, right here, like we just found in the last one, right? This is 2 pi over 16, and this is 3 pi over 16. So we're going to do something very similar. When we find the period for sine, it's the same for cosine, so we don't have to redo that part. So although I am making you find both equations, the only thing you really have to do differently is the phase shift. Everything else will be the same for the function. So amplitude, midline, period, you can just do it once for these. And so for period, our equation is going to be C divided by B. What is the B that we found? 4. We need it to equal 3 pi over 16. Right, because we want the phase shift to be 3 pi over 16 now. So if we cross multiply, we will get 16C equals 12 pi divided by 16 divided by 16. C is 3 pi over 4. So my equation here is going to be y equals cosine of 4x minus 3 pi over 4 plus 2. So both of those are options. You also could shift it to the left if you want. You could, you could do crazy stuff like flip it, then shift it. You could. There are infinite number of correct answers. These are the most likely for you to see on a quiz or test. I will not do like crazy things. I usually go the shortest distance. Yes.
Will they be open-ended or
I think there's some of them will be multiple choice. Some of them, what I will do is I will give you the graph, and it will be like A sine bx plus c plus d, and then you'll have to tell what A would equal, B would equal, C would equal, D would equal. There. The good thing about the ones like that is they give you partial credit, so almost everybody can get A and D right. So you usually get half of it, even if you're a little confused on the inside part.
Are you going to do number 4?
Not together.
What do you
Period
do?
messing you up on that one.
Well, what do you do if there's like pi and the stuff?
Let's do period real quick on number 4. All right, so what is the period? So midline's right here at 10. What's the period for that one?
Period.
Yeah. Period would be 2, right? It starts repeating at 2.
So you just don't just do it regularly.
So your formula for period is 2 pi over b equals the period, right? So 2 pi over b should equal 2 in this case. Since that's not a fraction, I'm going to put it over 1.
So B should be 1.
B is going to be pi. So if you cross multiply, 2b equals 2 pi divided by 2. B equals pi for that.
Okay.
So it would, like, whichever one you choose to use, y equals sine or cosine. I'm not doing all of it, but it would look like this, pi times theta or pi times x there.
So I just did 2 pi divided by 2. And then
If you're doing, you don't have to set up the equation if you don't want to. Like if you're just thinking of it in your head, that's fine. Yeah. Some of them are easier to do that than others. Like that's not too bad to do. This like phase shift of being 3 pi over 4, that's hard to do. So I usually rely on that formula there. All right, let's flip to the back. And which one is the craziest here? Probably 9. 9's probably our craziest here. Now this one tells us cosine, so you don't have to do 2 functions for this one. This one tells us cosine. All right. So, there are 2 parts that should be pretty easy to come up with, right? Amplitude is 100. We'll have cosine, and then we'll have, I'm going to go ahead and put bx plus c right here, and our midline's 50. So we should have a plus 50 on the end. So amplitude and midline are just plugged in.
You're not plugging everything.
No. Because period does not equal b. And phase shift does not, c does not equal 10.
This is period.
Right. But that doesn't mean b is 8. Because for the period, we got to do 2 pi over b. Right? And so when we do 2 pi over whatever this b right here is, we want to get 8. All right? So for these, since we're going backwards, you're not using the formula where you are taking that formula and setting it equal to what you want your answer to be. So if we do that, we can cross multiply. We'll have 8b equals 2 pi. And we can divide by 8. So b would equal pi over 4. So now we've got y equals 100 cosine of pi over 4 times x or theta, whichever variable you want to use here. So that takes care of getting the period right. We've already done amplitude. We've already done midline. Okay, and again, phase shift does not just get plugged in, except for extremely rare cases. Maybe sometimes they could be the same, but it's going to be extremely rare. So if I want to go to the left 10, I need c over b to equal 10. Also, if I'm going left, should have a plus or a minus there. A plus, so the plus should stay, right? So my formula for phase shift is c over b. What is our b? Pi over 4. And that should equal 10. So, that's like 10 over 1. If I want to cross multiply here, c would equal pi over 4 times 10. How do I multiply those together? You're not dividing here, so you don't flip.
You just multiply that by pi.
Multiply straight across, so that will give you 10 pi over 4, and that reduces to 5 pi over 2. So your equation would be y equals 100 cosine of pi over 4x plus 5 pi over 2 plus 50. For the back, it tells you either sine or cosine, so you only have to do one of those for the back. So for the front, I do want you to do one sine and one cosine equation for each one. On the back, it's going to tell you just do one there.
So first we find the period and then plug that into the ratio.
Yes, you must always, that's important to note here, you must always do period before you do phase shift. Unless the period is 2 pi, which means nothing happened to it. But you always need to find that B value before you try to find C, because you can't find C without the B there. Okay, other questions? All right, you got about 10 minutes to work on this. So go ahead and